practicing finding the volume of cylinders and cones on tonight's homework. I'm going to do problem number 4 with you, but in order to do problem number 4, you will have already needed to complete problem number 3. 3, 4, and 5 are all related based on this problem situation here. It says Mr. Backus has just finished his corn harvest. He filled 12 trucks with corn and needed to move the corn from one to one of the 2 silos on his farm. The 2 silos are shown down here, silo A and silo B. Each truck bed is shaped like a rectangular prism, having dimensions 10 feet wide, 20 feet long, and 6 feet tall. So in order to do problem 3, you have to find the volume of the trucks. And you can find the volume of the truck by finding the volume of the rectangular prism with the dimensions given here. And then don't forget that you have 12 of those trucks. You'll need to multiply that volume by 12 to get the total volume. That total volume of corn will only fit in one of these 2 silos. In order to figure out which one, we have to calculate the volume of each of the silos. This silo is shorter, but it's got a wider base. Its circular base has a greater diameter or larger radius, and silo B is taller with a smaller diameter base. The silos themselves, you have to recognize that they're made up of a cylinder and a cone. And the cylinder and the cone have they have a congruent circular base. So I'm going to break each of these silos up into 2 pieces. I'm going to call this volume 1, call this volume 2, call this volume 3, and call this volume 4. So that when I'm finding the volume of each silo, for example, the volume of silo A will be equal to the volume of the cylinder 1 plus the volume of cone 2. And the volume of silo B will be equal to the volume of cylinder 3 plus the volume of cone 4. And I can just work on finding these individual volumes. The volume of cylinder 1, volume of any cylinder, is equal to the area of the base. We use capital B to indicate area of the base. And since we have different circular bases in this picture, I'm going to indicate the area of the circular base 1 multiplied by the height of the cylinder, so H1. H1, the height of the cylinder, is 40 feet, and the volume of the circular base will be the volume of this circle with this 25-foot diameter. Since this 25 feet is pointing to this dashed line, and the dashed line goes all the way across the circle, that's the diameter. The radius would be half that, which would be 12.5 feet. So the area of base 1 is equal to pi r squared. So it's approximately 3.14 multiplied by 12.5 squared. 12.5 squared is 156.25. But once I told you on this homework and on recent homeworks that as long as you write the formulas and then substitute the values for each variable, then at that point it's okay to use a calculator. So you could use a calculator to find to simplify this expression from here. It's going to be 156.25 multiplied by 3.14, so 490.625. And I'm just going to say, since I'm approximating anyway, I'm just going to say 491 probably. Just round it to the nearest whole. If you round differently than I do, we're going to get slightly different answers. That's fine, because we're estimating anyway if we're using 3.14. So if we get slightly different answers, then both answers are still good. So now I can substitute the area of base 1 into this formula, and I get I should say approximately equal to here, since this is an estimate at this point. 491 multiplied by the height of the cylinder 1 is 40 feet. And 491 times 40 is 19,640. cubic feet, but we won't write the units down until we calculate the actual volume of the whole silo. Now I'm going to do the volume of cone 2. Volume of a cone is equal to 1/3. I'm not liking that color. Volume of a cone is equal to 1/3 multiplied by the area of the base multiplied by the height. It's the same formula as volume of a cylinder, except you have to multiply by 1/3 because we learned that a cone with the same circular base as a cone that has the same height and base of a cylinder. I'm not saying that the right way. If you compare a cone and a cylinder with the same height and the same circular base, the cone will be 1/3 the volume of the cylinder. So we have 1/3 multiplied by the area of this base circle 2 multiplied by the height of the cylinder. I mean the height of the cone, h2. h2 is 8 feet here. So I don't really need to recalculate the area of the cone's circular base because it's congruent to the area of the cylinder's circular base. So we already have that. It's equivalent to area of base 1, which is 491. So it's 1/3 multiplied by 491 multiplied by the height of the cone, which is the perpendicular distance from the vertex to the circular base, which is 8. And then you can use a calculator at that point. I'm just going to do 491 times 8 and get that product, which is 3,928. And then I'm going to divide that by 3 because multiplying by 1/3 is the same as dividing by 3. So I get 1309. I'm saying approximately equal to now because the area of the circular base was an estimate. 1309.3, repeating that 3 goes on forever, so I'm just going to say 1,309. So now the volume of silo A we set up here was equal to V1 plus V2, the volume of the cylinder plus the volume of the cone. So now I can substitute those volumes in. I have 19,640 plus 1,309. You see how small the volume of the cone is compared to the volume of the cylinder. The cylinder is much larger than this conical top section. And in a real silo, I don't even know if you would ever fill up above the up into this conical area. Probably not. But just for the purposes of this problem, we're going to assume that all of this volume is available for the corn. If you add those together, you get 949. You get 20,949. The correct units would be cubic feet. Cubic because when we're doing volume, we're talking about 3 dimensions, and so feet cubed. It's literally how many 1 by 1 by 1 cubic feet would fit inside of this silo, and this is how many would fit. I think I'm not going to do, just for the purposes of not making the video overly long, the procedure for finding silo B is exactly the same as finding silo A. You just find the volume of cylinder 3 and the volume of cylinder 4. So you can do that on your own. I thank you for watching the video, and I'll see you tomorrow.